Last time we just talked about the continuity, right? So actually, continuity, later on we will focus on three aspects. The first aspect is at a point. Then that means we will consider if the function is continuous at some certain point. Then we can just extend the idea to check if the function is still continuous within one interval. You know, one interval means there are many points inside the interval, right? Then the third aspect is we will evaluate if the function is still continuous within its domain. Did you remember when I give you a function y is equal to f of x? We can immediately get its domain, right? So we need to check if every point within the domain can still hold the property of continuity. Then if so, then we will say it is a continuous function. So later on, I will show you the later two aspects. But the first one is just like this one, continuous at some certain point. So and lastly, I also point out the definition for the continuity for an interior point. That means if we say one point, if the point is inside some interval, then when we just want to define f of x is continuous at some certain interior point C, then we need to find if its two-sided limit exists, and also if the function is defined at x is equal to c. And the most important thing is if the limit value is same as the function value at x is equal to c. Okay, so this is for interior point. But for the endpoint, we know for an interval, normally we have two endpoints, right? One is left end, like this point. One is the right end, this point. So when you talk about the endpoint, when we want to evaluate if the point is still continuous at the endpoint, we will check if the endpoint is the left end, just like A here. Then we will check if its right limits exist for A, and especially its function value at x is equal to A is same as the limit value when x is approaching A plus. So similarly, following this idea, if we want to define if the right endpoint is continuous at B, then we will check if its left end continuity exists. So just like this one, limit x when x is approaching B minus f of x. If this limits exist, and we also need to know if f of B exists, then the most important thing is if these two values are the same. So this is about the continuity at some certain point, just like I introduced it to you last week. So today we will continue to focus on this one. Then so let me just give you an example that did you remember last time? Oh, maybe I will use the new one. Okay, so I will give you an example. I remember in our first lesson, we learned this function, right? Did you remember? This is the flow function, right? So for the flow function, did you remember? It is a step function, right? It will be defined piece. It will be defined piece by piece, right? So as this one, we can see the function will look like this one. Here and Jenq here, and then Jenq here. blah blah blah, right? So same as this one. Something like that, right? Okay. So can you tell me when x is an integer, it will make the right for example, maybe we just focus on this point. If we just focus on this point, so can you tell me is right continuous or left continuous? Left or right? So let's just look at this one. At this point, limit when s is approaching 1 plus f of s, it will be 1 plus, it will be, what's the answer? S is approaching 1 plus 1, right? 1, okay? And limit S is approaching 1 minus, it will be 0, right? And let's just look at this one. It will be 1, right? 1 here, right? 1 is here. So which one the same? Which one is the same? These two ones are the same, right? So when s is approaching 1 plus, from 1 plus, its limit value is same as the function defined at s is 1. So it is right continuous or left continuous. Right or left? See this point? Huh? If you agree with right, can you raise your hand? If you agree with left, it seems that actually it should be right continuous. So let me just let's just go back to the definition here. Oh, sorry, maybe I just write a wrong definition for this one. Right, this is for right end. This is for left end. This is for right end. Right end is here, but we only pay attention to its the point at its right side. Right? Right? So, okay, maybe I still did not give you the right continuous or left continuous. So-called right definition is I need to measure from this way, from right hand side, its limit is same as the function value. But for the left end point, we only have right hand side point we need to focus on, right? For the left end point, we only have its right end point need to focus. But for the right end point, we need to only focus on its left end point. So, okay, so based on this, actually, I will tell you it is a right continuous. Why right continuous? Because this way, from this way, its limit value same as the function value. But from this way, you can see its limit value is 0. is 0, but its function value is 1, so it's not different. They are different. So based on this example, I will go back to give you the definition that if a function, we say it is right continuous. So that means I need to make sure it is continuous from the right. Right continuous means I need to make sure it is continuous from the right at some certain point C. We need to make sure the C is also in the domain. If limit S is point C plus f of x is equal to f of C. You can see limit S is the point C plus means the point we focus is coming from its right hand side, C plus. Then we need to check if its value is same as the function value at x is equal to C. So you can check here from right hand side, the limit value should be 1, and its function value also 1. So it fits the requirement for the right continuous definition. So you can see this is a right continuous. So likewise, you also can define a function is left continuous. So that means we need to measure continuous from the left if limit S is the point C minus f of s should be f of C. So let's still go back to the previous definition here. You can see, let me just show you again. For right end, for the, this is an interval, right? So as I just mentioned earlier, that for an interval, you will have two ends, right? One is left end, one is right end. So for left end, you only need to pay attention to the point at its right hand side. For the right hand point, you only need to pay attention to its left hand side. So for this one, if we say this is the left hand point, if we say it's continuous, we need to make sure its right hand side, the point at its right hand side, when it is approaching C, if the limit value is same as the function value for this point. So similarly, if for the right hand point, you only need to pay attention to the points at its left hand side. So we need to make sure the limit for its left hand side points is same as its function value. So this definition focuses on the endpoint, but this definition is focused on its right continuous or left continuous. So different. So if we want to combine them together, normally we will check for the left end point. For the left end point, we only check if it has the property of being right continuous. For left end point, we will check its right continuous, right? For the right end point, we will check its property of being left continuous. 懂我意思吗？这两个事实上没有冲突哦。对这个来说呢，我们所谓的右连续是什么意思？ 意思。右连续我当然是 care 的是什么？它的点从右边过来的时候，最后的极限值有没有跟我的函数值是一样？这叫右连续，对不对？左连续呢，我 care 的是从它左边过来的时候，一直靠近我这个点的时候，它的极限值有没有跟我的函数值是一样？这个叫做右连续跟左连续的定义。OK， 那刚刚今天稍微早一点复习的这部分，我们在讲 endpoint 的连续性有没有连续性的时候，我们关切的是一个区间里面通常会有两个点嘛，对不对？有左端点跟右端点，对不对？这个你可以理解嘛，对不对？对左端点来说，它其实不 care 它的左边的点，因为左边点不是我的 interval 内的点，我 care 的是谁？我的左端点的右边的这些点有没有它的极限值刚好跟我的函数值是一样？反过来，如果 care 的是右端点的右边的点其实不是我 care 的，右端点的左边才是我的 interval 的范畴。所以右端点的左边的点一直靠近到右端点这个瞬间，它的极限值有没有跟它函数值有没有一样？如果有，我们就说它这 endpoint 是一个连续的点，这样了解吗？所以这两个事实上没有抵触，只是这个方向大家要注意一下哈。Okay, so this is just a example. So that we will check we need to define the rule for the continuity test. So if a function f of x is continuous at s is equal to c, if and only if and only if means bidirection. So that means if we say E is continuous at S is equal to C, then we can make sure these three things just happen. These three things just hold. One is f of C exists, then limit x is approaching C, f of x also exists. Then finally, these two values should be the same. So from this side, if we say the function is continuous at s is equal to c, then we can measure f of c must exist. Limit s is approaching c of x, f of x also exists. Then these two functions, these function values at s is equal to c, and the limit at s is approaching c, f of x should be, and the value should be the same as this one. Similarly, if we can conclude these three things hold, then we can conclude that function f of x is continuous at s equal to c. Okay, so especially it's a it is not single n limit. This is 4. This is 4. This is, you can see here, this is 4. Double n limit. Right? Did you still remember what is single n limit? Single n limit just focus on from right hand side or from the left hand side, right? But for the double n limit, this is for from left hand side, from right hand side, the limit value should be, the limit values are the same. Okay, so this is for double n limits. So later on I will show, this is very important. This is very important. So I can just draw a simple figure for you. For example, if a function defines just like this, This is C. Okay, so for example, if the value is the limit value is C, so based on this, you can see from the left hand side, that means limit S is approaching C minus f of S is L, right? Limit S is approaching C plus f of S, this time from this side, is also L. So based on these two facts, we can conclude that limit S is approaching C f of X is L, right? So based on this figure, I just can say is double n limit at S is equal to C exists, and its value also L. But if C is defined here, if FC is defined here, okay, we can say it holds for f of C exists. And limit S is supposed to C f of X also exists. But the third property doesn't hold because the function value is different from the limit value. Only when the function value is here, only f of C is equal to L, then we will make the third rule holds. Then we will say this is continuous. So that means if f of C is different from L, is not equal to L, then we will say f of S is not continuous at S equal to C, even though limit S is approaching C f of S exists, and its value is also L. If f of C is equal to L, then we will say f of S is continuous at S is equal to C. So think about that. If f of C is equal to L, then we will say it is continuous. But if f of C is different from L, even though the limits exist, we will not say f of C is continuous at S is equal to C. So you need to check these three rules. Check if the function is defined at S is equal to C. Check if X is approaching C, f of S exists, and finally check if these two values are the same. Then after passing these three rules, and then you can say f of X is continuous at S is equal to C. So of course there are some examples for this continuity. This continuity is that means E is not continuous. So the first one is the so-called jump discontinuity. Okay, at S is equal to 0. So just like this one, if function defined as like this one, and you can see here okay, then if the answer is 1, so based on this, when S is approaching, or let me ask you, when s is approaching 1 plus, what is the limit? What is the limit? When s is approaching 1 plus? 1, yes, correct. If s is approaching 1, 0 minus 0, right? So 0 is different from 1. So the rule second, the second rule will not hold, right? Even though what is f of 1? F of 0? 1. Even though f of 0 exists, even though it's 2 single n limits exist. However, these 2 single n limits are not the same. So the rule 2 will not hold. So not to mention this one, right? Not to mention the rule 3, right? So we will call this as a jump discontinuity. The second one is the infinite, so-called infinite discontinuity. Infinite. The so-called infinite continuity is just like this one. F of s is equal to 1 over s squared. So the figure will, the curve will just like this one. So at this point, we will find, except for 0, all points could be continuous. However, only when x is equal to 0, we cannot conclude it's continuous. And especially, we will say it's an infinite discontinuity. Because you know, when s is approaching 0 minus, it will reach positive infinity. And when s is also approaching 0 plus, the function value also reach the positive infinity. So finally, they will just reach the infinite number. That means infinity. So we cannot. It's not a meaningful number. So that we will say it's an infinite discontinuity. And the third one is escalating discontinuity. At s is equal to 0. So when we say f of s is equal to sine 1 over x, I believe I showed you before. So the curve will just lie. Okay. Like this one. And the curve will also very like this one. So we cannot make it touch s is approaching s is equal to 0. So therefore we say in this case we will say it is a escalating discontinuity. We always cannot conclude limit s is approaching 0 plus, or we cannot conclude any meaningful value for this one or this one. We cannot conclude. Sometimes it's -1, sometimes it's 1. The value always vary from -1 to +1. So you always cannot conclude its value. So we will say this case is escalating discontinuity. Okay, so let me just continue to introduce what is a continuous function. So far we already know we already know how to judge if the point at some certain point, if the point is continuous for some specific function, right? So right now, can we just extend the idea to how to define a continuous function? So before that, let me just show you the first definition for continuous on some interval. If a function is continuous on an interval, as I mentioned earlier, that on an interval, there are many points for this interval, right? So if it is continuous at every point of the interval, then we will say it is a continuous, the function is continuous on the certain interval. So we need to check point by point in this interval and to see if the point is still continuous for this function. If all points within this interval are continuous, then we will say the function is continuous on a certain interval. So this is the first definition for that. The second definition is for a continuous function is one function that is continuous at every point at its domain. So if we say the function is continuous, then this function should be make sure that the function is continuous at every point at its domain. So let me ask you, y is equal to 1 over x. Is it a continuous function? I'm asking you, if y is equal to 1 over x, is it a continuous function? Or like this one, is this a continuous function? Yes or no? Try to guess. No? If you agree with yes, can you raise your hand? Okay, 1, 2, 3, and also myself, right? If you agree with no, it is not a continuous function. Oh, even more. Okay, let me tell you the answer. This is a continuous function. Why? Be careful. Pay attention to its definition. There is some trick here. If we say it's a continuous function, it must satisfy that the function is continuous at every point at its domain. Every point at its domain. So what's the domain? What's the domain? It will be negative infinity to 0, not including 0 itself, right? Union 0, not including 0, right? To positive infinity. So you can see 0 will not include it in its domain. Of course, we don't need to check if 0 is continuous for 1 over x. Understand that? So this is a continuous function, but this is not continuous on from -1 to +1. Why? Because for this interval includes 0. Right? Includes 0. So we cannot say it's continuous within this interval. However, we say it's continuous because its domain exclude 0. Right? So we don't need to pay attention to 0 if we want to check if it's a continuous function. So of course, for 1 over x squared, we also face the same situation. We don't need to take care of 0. We only take care of negative to positive infinity, excluding 0. But for this, it just asks you if within this interval, is this function continuous? No, because 0 could not be a continuous point for this function. OK？ 这个概念知道吗？就是说，如果问你函数是不是连续函数的时候，你第一个要先把它 domain 找出来。domain 的点你要去 check 是不是都是连续的。所以当每次遇到这里，大家都会有个迷思，就1除以 x 是不是连续函数？它是连续函数，因为我们只 care 它的 domain 是在这个区间，不包含0的，所以0不是你要在意的。因为我的 domain 天生就没有包含0这个点嘛，但除此之外每个点都是连续的 ，OK？ 但是如果人家问你说，在负1到正1之间这个区间1除以 x 是不是连续，那就错了，因为0不连续，所以它就不会在这个区间连续，这样懂吗？所以这两个问法是不太一样的 ，OK？ Then okay, I will also show you some property about continuity. So like theorem 8, if f and g are continuous, at s equal to c, then through 4 operations, additing, subtracting, multiplying, and also being divided by g is still continuous at s equal to c. And besides, like k times f or f to the power of r over s, they are also continuous at c. So this theory is very simple. Through 4 operations, like addition, subtraction, multiplication, division, these 2 functions, if the original 2 functions are continuous at some certain point, even through these 4 operations, the new result is still continuous at this certain point, s equal to c. And also for using a constant k times f, or you just taking its power, like f to the power of r over x, it is still continuous at this point. Okay, maybe it's very intuitive. And the theorem 9, then we will talk about the composition. If f of s is continuous at c and g of x is continuous at s is equal to f of c, right? Then we can say G composite f of x, that means it is equal to g of f of x, right? I defined this before. Right? We will say it is still continuous at s equal to c. So you can see the first function we face is f of s. So if we say f of s already continuous at s is equal to c, then we continue to use the value as the input, f of c as the input for g of x. Then we also say the precondition is g of s is continuous at fs is equal to f of c. Then when we just composite these two functions together, we have the new function, g of f of x function. It is still continuous at s is equal to c. Okay, so it's also very intuitive, right? And the third one, the last one, if g of x is continuous at b and when limit s is upon c f of s is equal to b. So the result is also very important. Then when we talk about limit s is upon to c, g of f of x, the result will be g of b. Or we can say this is g of limit s is equal to c f of s. This rule is very important because in next semester we will use this theorem to prove some theory. But maybe for you, maybe you just think, oh, it's also very intuitive. But actually, it's not that intuitive. So please just think about that. You can see limit s is equal to c, g of f of s. That means the first step for you is, this is the first step, right? Step one, you need to composite these functions together. These two functions together. The step two is this one. Then you try to take its limit value, right? So for this form, we can see the step one is try to get its composition of g of s and f of s. The second step, then we try to get its limit value. But the result is just like this one, g of b. So g of b, you can just convert it as g of limit s is equal to c f of s. So you can see this one, supposedly this is different from this one. This step one is, you can see this is step one. Step one is about taking the limits when s is equal to c of s, right? This is step one. Then the step two is focused on, after you get the limit value, then I use the limit value as an input for g of s. So the step two is using the limit, using the result as the input for g of s. But for this one, the first step is taking the composition of g of s and f of s. Then we take limit. This is take the limit first, then take the function value later. So it's different. But of course, suppose I need to prove it for you, but as I say, you are studying in engineering department, now mathematics department, so we just use it. But I believe you also can understand that why I just emphasize, actually these two ones are different things. These two ones are different things. One is take the limit first, then take the function value. This one is take the composition first, then take the limit value. They are different. Okay, so let's just take break and come back later. The next concept I want to introduce to you is continuous extension to a point. So what is continuous extension to a point? So based on this, you can just image that at some certain point, originally it is not continuous, but to some extent, can I just make up it so that I make it become a continuous? So let me just show an example to you that we already know this function, right? So it is a function continuous at every point. Okay, before that, let me just ask you, sin x over x, is it a continuous function? Is it a continuous function? Yes, right? Because its original domain will not include 0. Did you remember last time I also drew the figure to you, right? The figure is just like this one. This is sin x over x. So 0 here will not include it in its domain. So of course it's a continuous function. So sin x over x is continuous at every point, but except for 0 for this point, right? But we know limit s is open 0, sin x over x. What is that? What is that? 1. Yes, it's 1, right? So that means when when x is approaching 0, no matter from this way or this way, we know both limits are 1, right? So that's just based on this fact. So we know the limit s is 0, sin x over x is 1, right? So right now we just define a new function as that if x is not equal to 0, we just simply use original one, sin x over x, right? It's correct, right? But if x is 0, I specially define its function value as 1. So you can see, based on this new definition, you can see the function will become so this new function, this is y is equal to big f of x. So we just, through the special definition for s is equal to 0, then we can just make it all continuous at all points. So we will say this is a so we can say this is a continuous extension to s is equal to 0. So we can make up it. Original, it looked like a broken curve, but after we just specially define its function as its limit value, then we can just make it become a continuous function. Okay, so right now you know that, right? Okay, so if I ask you to show that f of s is s squared plus x minus 6 over x squared minus 4 has a continuous extension to s equal to 2 and define its extension. Maybe we still can save some space. I just use this space. Okay. So based on this, actually you can just try to simplify this rational function. The original rational function is this one, right? So we can just factorize them, become x minus 2 times x plus 3 over x minus 2 times x plus 2. So when x is not equal to 2, we can just simplify it, become x plus 3 over x plus 2, right? Because when s is not equal to 2, these two factors are the same. Of course, we can cancel them together if x is not equal to 2. So these two ones can be cancelled. So based on this, the original function should be like this one. If the original one is x squared plus x minus 2, x squared minus 4, so the curve will like not including 2, and something like that. So based on this, originally its domain will be R, but exclude positive 2, right? Its domain should be like this one. But we also know based on this, if s is not equal to 2, but we can try to get its limit when s is approaching to 2, that f of x, then what is the limit? What is the limit? Can you tell me what is the limit? 5 over 4. So that means even though the original definition original function will not include 2 as its domain points, but we can know this one. So that means here should be 5 over 4. So the extension, so we can try to get the extension. We can define it as big F by following, if s is not equal to 2, we just follow the original one. But if s is equal to 2, we just force him to become this one, so that we can get this one. Finally, we can get at least some certain point is 2, 4 over 4. This is a new one. This is a new function. But let me ask you, can I define it as like 100? Of course you can do that. And also the new function big f of x is still a function, right? It's still a function. But if you just force the function value as 100 when x is equal to 2, it will not a continuous function. It will become just like this one. 100 is here, right? And this one will become empty. Then you can see the curve continuously moving from this way. When you touch this point, it will jump here, then going down back to here. So it will cause it become a discontinuous function. So only when you just force s is equal to 2 as 5/4, then it will become a continuous extension. It's a continuous extension. So this new extension is just what we expect, what we expected. Okay. Then this is about the continuous extension. Then I will show you the very important theorem. We call it the intermediate value theorem for continuous function. This is very important. Intermediate 中间值定理. This is a very important theorem. 中间值. I should say this is the first important theorem for calculus. It's an intermediate. So what is the intermediate value theorem? That if a function y is equal to f of x, it's continuous on a closed interval a and b. Okay, this function will take on every value between f of a and f of b. This is the formal definition for the intermediate value theorem for continuous functions. But maybe if it's just defined like this, it's hard for you to understand that. But before I go to the simpler one, I will just try to explain to you that if f of x is a function, y is equal to f of x is continuous on this interval, then what does it mean it will take on every value between f of a and f of b? That means f of a is a value, right? F of b also another value. So all function, all value in between here will happen at s is between a and b. So if I just convert it in another word, normally we just use the following one to use this one. If y0 is any value between f of a and f of b. See, every value between f of a and b, you can regard it as this one, right? Then y0 must be f of c, where c is for some c in AB. So let me just draw a picture for you that if the function is continuous, so if this is A, this is B, and y is equal to f of s is a continuous function between A and B. Continuous. No broken point, right? You can see when I draw this curve, no any broken point. So this is f of A. This is f of B. So if I give you any, I give you y0. Y0 is between fa and f of b. For example, f of y0 is here. Then if it's a continuous function, you can find a c between a and b, so that f of c will be mapped to y0 for some c and possibly many c's. For example, let me just show you another example. Another example is this one. If y is equal to f of x, then the curve is this. Okay, this is A, this is B, so this is f of A, this is f of B. So if some y0 here between f of A and f of B, you can find C here or C here, but at least you can find one C, so that f of C will be y0. Let's say it's a so-called intermediate theorem, intermediate value theorem. So you can find, in this case, we can find 1C. In this case, we just find 1C. But in this case, we can find 2C, satisfying its function value is equal to y0. But maybe 1, 2, or even more. But at least you can find 1. At least you can find 1. So any value between y0, any value y0 between f of A and f of B, you always can find 1C between A and B, so that f of C will be y0. Okay, so this is the so-called intermediate value. So the intermediate value will based on this function should be continuous. If this is not a continuous function, then we cannot guarantee that will be happened. 好，这个也是很重要，我很快讲一下。这个是微积分里面我想碰到第一个很重要，而且也有一个很重要的名字，叫做的一个的定理了哈，叫做中间值定理。大家不要误会，中间值不是代表它的值是刚好是正中间，而是介于中间的概念，所以它叫做 intermediate。intermediate 就是 in between 的意思哦，并不是说它刚好就是 a 跟 b 除以2的2/2 a 加 b 那个意思哦，不是哈，只要介于中间哦。那它是怎么讲的呢？就是说，如果函数，它最重要的强调是它是一个连续函数的概念。它是一个连续函数，连续就不会断掉嘛，对不对？大家想想，连续就是不会断掉，中间不会有断点，对不对？然后呢，他说它在一个 B 区间里面是连续函数哦，这句话初步如果第一次学的同学会可能比较看不懂，但我还是 follow 原来课本的定义，还是跟大家讲一次，就是说他写说 test on every value between f a and f b， 他意思是说这个函数啊，我保证你一定会出现任何值是介于 fa 到 f of b 之间的值。什么叫会出现？一定会出现值介于 fa 跟 f of b 的值。意思就是说，我在 a、b 之间啊，我一定可以找到某一点 c。好 ，a、b 之间我一定找到某一点 c 对应过来 是 y0，就是你取的这个你要的这个值就介于它中间。也就是说，我只要给你 f of a 跟 a 跟 b 之后，你有 f of a 跟 f of b， 对不对？任何值只要介于 f of a 跟 f of b 之间，我呢一定可以找到某一点 c， 至少一点 c 呢，使得它的函数值刚好会等于这个 y0。所以我就画了2个例子给你看，一种图是这样子，对不对 ？f of a 在这里 ，f of b 在这里，所以我可以找到一点 c 介于 a、b 之间。如果 y0 指的是这里的话呢，我就会有至少 c 这个点带进去函数值得到 y0 的。那如果以这个 case 来说 ，f of a 在这里 ，f of b 在这里，对不对？它们既然是连续的，假如 y0 是介于 f of a 跟 f of b 中间的任何一个点，以这个例子来讲，这个 c 可以让 f of s 的值成为 y0， 这个 c 呢，另外一个 c 呢，也可以让 f of x 的函数值为 y0， 所以这里呢，我们就可以找到2个 c， 我们可以找到2个 c， 可能可以更多啦，看你的函数的长相，对不对？那这就是连续函数。但是如果不连续函数，就这件事情就不一定对了哈。我们就试想一件事情哈，这位同学有从北到南来这边念书的，对不对？国道1号，它是不是一条这个连续的曲线，一直到高雄，北从基隆一直到高雄嘛？是高雄，反正高雄还是屏东，随便哈，反正从头到尾啦。我们讲台北到高雄好了，台北到高雄就是 A 跟 B 嘛，不代表它所有的 domain 嘛，对不对？好，这条是一个连续的这个高速公路，对不对？所以我们如果说今天要经过，我已经知道比方说台中，我们随便讲，我们说新竹可能是在100公里的地方啦，随便说了，这个数字呢随便猜的啊，新竹可能是在100公里的地方，然后呢云林可能是在随便说它或台南好了，可能在330，对不对？这个我都随便讲的哈，这不一定正确哈。我在讲的是新竹可能是100公里的地方，台南可能在300。那今天我告诉你有一个192的地方，我一定可以找出一个点对应它，那叫台中。台中好像180、190还是就是那个 range。你不可能，如果它是连续函数的话，你高速公路走下去，你一定会经过台中，对不对？你不可能到丰原的时候突然搭直升机飞起来，然后到彰化再掉下去嘛，对不对？所以如果它是连续的高速公路，你一定会经过它，所以它是有断掉的，对不对？概念类似像这样，就是如果它是一条连续的线，它如果是一条连续的线，你要经过，比如这是 A 跟 B， 然后你一定会经过一个高雄，一个台南，一个是新竹，你一定会经过一个叫台中的地方，它的长度它刚好是178左右。但是如果它不是一个连续的公路的话，它就不可能，它不是一条连续的公路，它就不可能，它就可能会断掉了哦，只有在连续的时候哦。Okay, so how can we just apply the intermediate theorem to solving some problem? So the simplest one is a consequence for root finding. 找根 root finding 叫做找根哦。那什么是找根呢 ？For example, if f of is equal to 0, if we say c is the root of f of x is equal to 0, that means That means the equivalence to, we can find C such that f of C is 0, right? So if we want to find this C, the first one is try to find A such that f of A is positive. Then we also try to find the other end, B, such that f of B less than 0. So between positive and negative, 0 is an intermediate point between a positive number and a negative number. So that based on this, we can find the C such that f of C is 0 and C should be between A and B. Then we say C is the root of f of S. Because this is positive, this is negative. So another way is, can you find as A, this is negative, then we can also find another one, B. It will cause f of S is positive. Then we also can find C between A and B, so that f of C is equal to 0. From positive to negative, you will passing 0. From negative to positive, you also will passing 0, because f of S is a continuous function. So let me just give you an example that I will show you an example. Wait, because this part is quite easy, so I just skip the example. But right now, I'd like to show you an example. Okay, I show you an example. That for example, if f of theta is equal to theta cubed minus 2 theta plus 4, please show that there must exist one root at least which between 0 and -3. So how can we do that? For example, when you just use f of 0, just simply use this one, 0, then you can get, it will be 0 cubed minus 2 times 0 plus 4. The value is 4. Then you try minus 3, then you can get minus 3 cubed minus 2 times minus 3 plus 4, then you can get minus 17. So this is positive, this is negative. From positive, from negative to positive, so some number must exist between -3 to 0, causing the function value is to be 0, right? So by the intermediate theorem, because this is a continuous function, f of theta cubed times minus 2 theta plus 4 is a continuous function. So one is positive, one is negative, so that we can find, and f of 0 is positive, f of minus 4 is negative, so we can find at least one c such that f of c is 0, where c is in -3 to 0. But we still don't know which one is the root, but at least we know some c in the domain -3 to 0. At least we can find one. At least we can find one. Find one which function value will be 0. That it will be the root, right? So you can continue to do that, repeat it again and again. So right now you already know 0 and -3, right? So you can also even try, for example, if you already have this space, you can try f of like -2. So that, what is the number? -2 cubed, -2 times -2 plus 4. So what's the value? Oh, 0. I just hit the root. 0. Wow. So we can say this is the root. But since this is the degree is 3, so we still can. No, maybe this is not a good idea. Oh, so I should buy the lottery, right? Because I directly hit the answer. So maybe this is not a good idea. Good example. For example, maybe I will try. Okay. I will try f of -1. So -1. Actually, I cannot say it's not correct. Actually, this is the root. I directly get the root. But right now, I try to find the range, right? So f of -1, it will be -1 to cubed -2 times -1 plus 4. So the answer will be how much? 5, right? 5. 5 is positive. 5 is positive. So in the past, originally, based on these two ones, you just know the root will is located in -3 to 0, right? But this time I try -1. So after this, I can conclude the root is located in where? Should be -3 to -1, right? This is positive, this is negative. So suppose it will be between here. So I believe you also played a game before. For example, I just asked you to keep one number in your mind from 0 to 99. Right? For example, maybe keep in my mind maybe 66, 67, something like that. And you try to guess, right? And my first guess is 50. Okay. You did not hit my number, but I can tell you 50 is not correct. But over 50, less than 99. So you will try to next try that. Okay, maybe this time I will try 80. So you just evaluate your number is 67, right? So this time I will answer you. Okay, more than 50, but less than 80. So gradually, finally, you can get the number, right? So of course, if you can try less time, then you can get more reward. So actually, this is my first application developed when I developed the application for the some telecom show. At that time, we just used our phone to send the show message to our application. Then our application will return that something like that. I tell you, okay, more than 50, less than 80, then please just try again. And gradually you can hit the number. But if the total the number of guessing is less than 5, maybe I will give you the reward. But if you try more than 5, and then I will not give you any reward or any money or return any benefit to you. Okay, so that's also kind of intermediate theory. 我想就是你们小时候应该有玩过一个游戏嘛，对不对？这个实际上就是我那时候，我记得2000初年的时候，在电信展的时候，我用 VB 写的一个程式。其实你们知道发简讯要钱，对不对？现在没有人在用简讯了啦，很少很少。以那个时候，事实上除了打电话之外，发简讯是最赚钱的，因为你发一则就收3块钱。那最高兴的是什么时候？在过年的时候啊，你想我放一个简讯给你，你会好意思不发一个简讯给我吗？然后我就赚6块钱。电信商啊，我是电信商，所以那时候他就希望引领你们去玩这个发简讯的游戏。其实简讯在电信系统里面，简讯它是用的 control signal， 实际上它是没有什么成本的。那没有用它还摆在那里，不像语音它会占住那个频段，但是简讯是用 control signal， 所以它其实不会占用太多系统资源。但你每发一则就3块钱，这个很惊人哦。一个过年，一个耶诞夜，电信公司可以赚100多万折哦，这一折就3块钱，就等于说一个晚上可以赚300万。不过现在不会有人用了，因为现在大家用 Line 用 Instant Message。那时候呢，对不起，我也是那种助纣为虐的。我那时候设计一个 game， 什么 game 呢？就是那种猜数字游戏就是说我的系统会产生一个 random number 在我的系统上面，那你就用你的简讯呢送上来。那我的系统，我刚举例来说，我如果系统的数字是67，对不对？那我会跟你讲0到99嘛。那如果你一口气就猜中67，那我服了你的，那你就会给，比如一口气就中了，我可能就给你100块这个月的免费通信费。如果你没有猜中，我就赚你3块钱嘛，懂我意思吗？好，所以如果你送一个数字上来，比方说，我们通常会从中间猜50，对不对？你送一个50上来，我答案是67啊。所以呢，我会告诉你，大于50，小于99，我是不是送一则简讯给你了？这则不用钱的哈，这则不用钱，不然等下这是吃人吃骨头吃人不吐骨头的。所以我就送一则简讯给你，那简讯上面就秀说，大于50，小于99。好，你就second try， 对不对 ？second try， 如果第二次你 try 67，哇，那也是很厉害，第二次就 try 中了，那我就送你50块钱下个月免费通信费。但你很可能猜错，因为数字那么多，所以你可能猜80。送给我80，我看，我是67啊，不是80，所以我就送另外一则简讯告诉你，这个数字会是在于大于50，小于80。那你就可以慢慢怎样去逼近这个数字，对不对？超过5次之后，它就不会给什么任何好处了那超过5次，我已经赚你15块钱了，对不对？这就是博弈嘛就是你就是想要博那100块钱或50块钱的这个免费通信费。那这跟这有什么关系？有没有很类似的关系？如果今天看根一正一负之间，我是不是应该，如果我再try一个数字，它可能是介于它们中间里面的一个正数，那我就知道它应该是一正一负的中间，介于中间再次讲，中间值定理不代表正中间，而是 它只是介于中间。那你就可以类似这样一直去踹出它的根。那像刚刚这个是太厉害了哈，不是太厉害，我就是随便乱猜，现在就被猜中一个-2啊哈，-2是根。那当然这个就是我刚刚讲的，就你一下就猜中了，那就恭喜你了。但如果你没猜中，你是不是可以如法炮制这样子的方法，就一正一负针去抓取它可能的值哈？哇 ，we almost run out of time. Okay, so we just come to the end of the session 5. I'm afraid we need to just stop here because we just 1 minute left. 所以我们今天就上到这里了哈。